3 o'clock in the Netherlands, in Noordwijk, Rock City. We just heard that the Netherlands is going to be confined and we are going to actually have a lockdown at 8:30. So everybody at home, curfew 8:30, and watch the online technology meetings of EPIC. Welcome to the number 62 of the online technology meetings today, a smart glass for augmented reality. Remember those early days of augmented and virtual reality glasses? We looked like we were ready to go diving rather than play games. So why were these things so huge? Because pioneers were focused on using off-the-shelf components for a faster time to market. The optics and electronics were all discrete. Google Glass was an early experiment with limited functionality, but it became clear that augmented reality's commercial future needed stylish, smart glasses, not smart goggles or spyware. Over the last 2 years, and away from the glare of publicity, amazing things have been happening inside the labs. So on Wednesday, January 20th at 3 p.m., we are going to reveal the latest state of play with augmented reality tools and developments in the physical interface between the human eye and those smart glasses. Now, I've always found glass to be such a wonderful material, halfway between a solid and a liquid. It's transparent, inexpensive, and can be specially manufactured to include microspots that are invisible to the human eye. So what's going on at SHOT and Corning? I also hope to involve leading optics players like Olympus, Leica, Zeiss, consumer giants like HTC, Sony, Microsoft HoloLens, Google Niantic, Facebook, as well as augmented reality hardware future gazelles like Dispelix, WaveOptics, Limbac, MICLEDI, Knoll Technology. Wow, I'm really gonna have fun here. In fact, a smart glass feeds your brain with real-time relevant information while you focus on what lies ahead. So here is our invitation to take an active role in the meeting on January 20th. Our Zoom room will engage with both emerging and traditional end users of glass to explore business opportunities. We meet exactly at 3 p.m. because being EPIC means having an augmented vision of what lies ahead. I'm having so much fun making these videos, but also I'm learning so much from the companies who are actually driving this world. And I'm so happy to see that many of them are actually part of our EPIC family, which, by the way, welcome, Joya. We keep growing, 665 members, all active in the photonics industry, from designers all the way to end users. I love what we're building here. Sana, great job today, by the way. I also would like to say that on behalf of fantastic team, EPIC has now 15 employees, 7 PhDs, and our job really is to really fully understand the technology of the 665 members of EPIC. And for those of you who don't know EPIC, and I think that's weird, but anyway, we organize events, we provide access to the network, and that's where we succeed. But also we do raise capital for the companies who need to raise capital, and we never get a commission. We have the biggest website to find a job in photonics, jobsinphotonics.com, and we provide all our members with fantastic market reports. Today is the number 4 of the season 3. This is like a TV show of Netflix. Number 4, season 3 of the EPIC online technology meetings. And today we are talking about the smart glass, but look at what's happened on Monday, 25, 5G. And I have BT, Adva, and Ericsson talking to us about the next generation 5G base stations. I can't wait for next Monday. I hope the weekend goes fast. But also, this year, we are for the first time also supplying online meetings for the quantum industry. I have a PhD in quantum physics. I love this technology, and I love the business that is generating already today. So if you have any kind of business or interest, or you just want to know what's going on, or you just want to know if your photonic devices actually have a market here, please make sure you attend the most relevant of the online technology meetings also for quantum technologies. And that's all about EPIC. Today, smart glass. Yes, finally. So first of all, I would like to acknowledge our media partners, Electro Optics, AZO Optics. Thank you so much from the bottom of our heart. Thank you so much for the active promotion and communication that you're doing for what we are doing here with the EPIC Online Technology meetings. And of course, this meeting wouldn't be possible without the support of our sponsors today. Today, the event is sponsored by Morphotonics. Morphotonics, all the way from Belhoven in the beautiful Netherlands, strives to make cost-effective AR glass optics possible by applying the large roll-to-plate nano-imprint. I see the machines, they are fascinating. Obducat, all the way from the southern and most beautiful part of Sweden. Obducat actually is a company providing equipment for the manufacturing of optoelectronic devices, from roll-to-roll, roll-to-sheet, all the way to the micro-optics, volume production, nano-imprint lithography, anything you need to do, you need to have for the volume production of optoelectronics. If you're an optical designer and you don't know Zemax, I would actually judge you. Zemax is my favorite software company. I use it a lot. So Zemax is a software company for optical production design. And actually, one of the things that they have now is a virtual prototyping, including the Optics Studio, I think the industry-leading optical design software, and the Optics Builder for a LED solution for a streamline how big product reach the market faster. But if you go to Florian and Ing, next to a river that actually connects Germany and Austria, you have to visit EVG. EVG is a supplier of wafer processing equipment, from nano-imprint lithography all the way to semiconductor production, and the excel on optics for AR. And we're going to hear from some of their customers today as speakers. And finally, I had to go to Neuchâtel and I had to see SUS MicroOptics. Reinhard Volkel is here. SUS MicroOptics is the company who actually is driving the micro-optics revolution in Europe using nano-imprint lithography technology and being automotively qualified. They actually have managed to make a revolution on the way the micro-optics can reach almost any market. You are looking for high-end micro-optics solution. You have to talk to Reinhard Volkel. You have to talk to SUS MicroOptics. That's all. Sana, what an amazing job you have done. Congratulations, Sana. This is a fantastic supply chain. Tell us, what's in the menu today?
Thank you so much, Jose. This is a great introduction, but the people we have today are just unbelievable. We have, of course, the great speakers, but can we look at the supply chain here? We got in the room all these companies. They're not just interested, they are working actively on pushing forward this technology. We will have, of course, our end users. We have representatives from Huawei, from Samsung, and so on. But we also have the market leaders in developing enhanced vision solutions. We will have in the room Luxottica, INOPTEC. We will hear from big companies doing optics and even the software, the designing. I'm so excited for the meeting today. And these are the companies that just signed up for this meeting. Right, Jose?
Exactly. These logos correspond to the companies who registered for the meeting today. If you're an EPIC member and you are missing your logo on this slide, we never, ever forget about you. Never. But actually, you didn't register for the meeting, so please don't let this happen again. If any market is suitable to your technology, do make sure to register and take part on these online technology meetings. This meeting is also, as usual, live stream in YouTube. So for those of you watching from YouTube, just remember, use the chat to post questions, but also don't forget, if you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-azoc.com, and I will make that introduction. This is also valid for the people in the Zoom room here with me. If you want to, you can use the internal chat, and that's magic, because during the meeting, when people are presenting, you can already talk business between each other. But also after the meeting, if you want to get in touch with any of the fellow participants, all you have to do is send me an email, jose.pozo@epic-azoc.com, and I will make the introduction, just because I love doing that. So I have no life apart from photonics. Let's start the meeting. I really, really, really love this. It was really fantastic what you did, Sana, today, bringing everyone. But I have to say, if there wouldn't have been this stupid coronavirus, right now we would be at Bosch Sensortec on a presence meeting on a smart glass for AR. Really, we would be there, all of us, and afterwards we will all go for a beer. But because we have a coronavirus, we do this like this. We start the meeting with Peter Ostertag from Bosch Sensortec. Peter, thank you very much for being with us. You are the first speaker, the keynote speaker today. Let us know what we can do for you. Sana.
Yeah, sorry, Jose. Peter, I have a little technical issue. Can we skip to the next speaker, please?
I feel really stupid right now. I go to the second speaker of the session, and I go to a company that I actually love, a company that has been driving the revolution of WaveOptics. We go to Arseny Alexeev, who has been well known for fantastic shopping lists at these online meetings. Arseny, thank you very much for opening the meeting today. We start strong today. We start with WaveOptics. Arseny, the floor and the attention of everyone is yours.
Okay, so thank you for the introduction, Jose. I'm actually going probably to disappoint you a bit today. I don't have a shopping list today, but I've got something.
We'll make one together.
Yeah, but I've got something new in my slides which you might like. but let's see. So let me just briefly introduce WaveOptics to everyone. So we are a company which designs and manufactures waveguide and light engines for augmented reality devices. So as you can see from this slide, we started trading in 2014. We raised in significance of 60 million up to date, and we're quite a large startup these days. We're 120 people now. From this map, you can see we've got a global presence. Our headquarters are in Oxford in the UK, but we've got business representatives in the North America, in Asia, in Europe, of course, and we also have R&D and manufacturing partners both in Europe and in China. And inside the team, we've got a brilliant team of different type of engineers, starting from modeling and then going into manufacturing, metrology, optical testing, and of course, we're developing solutions to meet the need both of enterprise and also of the consumer market. So I will just briefly go through the next slides. I just want to show you our product line. So what you can see on this screen is a range of waveguide displays which we design and manufacture. They come in different shape, size, and taste. So you can see we've got a 1-plate, 2-plate, 3-plate solutions with different field of views, and there is also a table of characteristics, but I don't want to go through all of them. I can answer some questions if there are, but let's move on. And I've got another similar slide for light engines. So once again, we've got a range of them to actually pair with our waveguides, just like there is wine pairing for any food. So we follow the same ideology here, and they also come in different size, shape, and with different characteristics. The next slide is actually the one I would like to spend a bit longer on, because the topic of this meeting is next stages for augmented reality glasses. So what I tried to do on this slide is just to show what it takes to create a consumer AR glass solution. And it is a fishbone diagram, which is shown here on the screen. And of course, the full solution, it's not just waveguides and light engines, but it's also other components like battery, obviously, is one of the important ones. And also what needs to be considered is image and information processing unit, as well as equally important, some killer applications for the consumer market uptake. And within those categories, there are different factors which are affecting the final design. And sometimes those factors are connected with each other through the parts of the device, as shown here on the screen. So I'll just go through some of them. In terms of waveguides, there are lots of different characteristics like field of view, eye box, brightness, MTF, color uniformity, resolution. There is also off-state performance, which needs to be considered, which consists of see-through characteristics, reflections. Similar characteristics actually exist on the light engine side, and they're connected with the waveguide because those two components, they have to operate together. The final part of this chain is battery, because battery is powering light engine, and the power consumption of light engine is connected to battery lifetime. And this is in turn connected to other characteristics of the light engine. So there are some other factors which you can see on the screen, like, of course, form factor, size, weight. Those are really important for the consumer applications because we want all those components to be small, light, not bulky. And finally, of course, we need some killer applications. So we need, we can design this headset, but we need to know what we're going to use it for. On the next slide, I'm going to show some considerations, which some of those aspects are actually borrowed from online webinar of Joya team. They're here today. But the message on this screen is that if we're designing a certain augmented reality solution, we need to consider the application, and that's where the story starts. So depending what the device is going to be used for, whether it's going to be used, for instance, like a motorcycle helmet or some glasses for an engineer to display some information in a see-through manner. Depending on the application, we can then move into creating technical requirements, and they can be quite different depending on a particular application. Like, for instance, if it is a motor helmet, you have much more room to integrate battery, to integrate a processing unit, and the requirements are much more strict for lightweight glasses for everyday use, for instance. So those are kind of those considerations which are important for the next steps in the field of augmented reality smart glasses. And what we can do at WaveOptics, we've got this flexibility to design and meet user requirements. So we start with the application, and what we can do, we can change shape, we can change dimensions, we can design up to certain technical characteristics. And by doing this, we can actually enable this sci-fi-like applications of augmented reality glasses. So the main message of this talk today is there is no shopping list, but there is a message. And the message is that we need to be smart when we design smart glasses, which means that we need to consider applications, and we need to have this flexibility to change technical characteristics and shapes to meet user requirements. And this flexibility exists within WaveOptics, so we believe we can deliver those kind of solutions. So that's the end of the talk. I'm not sure if I managed to fit into 6 minutes, but
thank you so much. It was a very nice talk, very enriching, and there was an excellent slide where you presented the big challenges for the, or if you wish, the checklist for the AR glasses. So you showed us what you can do, and I cannot let you go without asking at least what kind of collaborations are you open for? We know what you can do for the others, developing these great waveguides, but what can the others do for you? What is it that you're looking for to push forward this your industry?
I mean, I guess our shopping list remains the same as during previous meetings. We're always looking for providers of advanced manufacturing technologies for waveguides and light engines. So a few things which were mentioned during some past meetings are materials with extremely high refractive index, some certain capabilities to fabricate nano-imprint masters. So anything related to manufacturing of both waveguides and light engines is certainly of an interest.
Excellent. Let me see first if our guest here have a question before starting to. Does anybody have a question? Because as I can see, we are over 60% in the room, so you can just unmute and ask the question. Otherwise, I would like to hear from SUS MicroOptics as we spoke about manufacturing capabilities. Can you unmute, Ralf?
Yes, yes.
Yeah.
Can you hear me now?
Yes, I can hear you.
Yes, yeah. So we have two things. The first thing is all what you use in the glasses is MicroOptics. So that's what we do. And the second, we have SUS Microtech selling the nano imprint and imprint machines. And it's clear we help them to make these machines better. And one of the big things for all these glasses is cost, manufacturing cost. And weight. We want to have this very, very light, and we want to have this for $30. So we have to help all those guys who try to manufacture it to get things cheaper.
Oh, yeah, true. I have my friend Alex from MICLEDI. So I see your raising hand.
Yeah. Maybe a question to Arseny, following up on his food and wine combination of the light engine and the waveguide. Arseny, on thinking of the future, what's your take? Will there be a most popular best of the best one combination that you will come up with? And how do you see it? Which one is going to be, if you can guess about that?
I mean, I guess it's not a straightforward question to answer, to be honest, because the reason why we have this plethora of different waveguides and light engines is because we really looking how we can tailor them for particular use cases. And whether we will develop a one-size-fits-all solution, I don't know. For me, it's still an open question. Perhaps we can also involve Dispelix into this discussion, because their approach is slightly different, to the best of my knowledge. They're developing a single plate solution, which is a kind of, I guess, with the perspective that this solution will be a good fit for most of the potential applications.
Thank you so much for the answer. Can you tell us more about MICLEDI, Alexander?
Well, yeah, we are actually on the one side of this combination. So we developed a new technology for micro LED displays for AR. So we are making very compact light engine with very high resolution and high brightness, manufactured in 300mm CMOS environment. And this is something that, from what we see, this is going to be one of the components to enable the future consumer AR, meaning that very small glasses, compact form factor, good image quality, long battery lifetime.
Mm-hmm.
So that's my interest to the waveguide light engine combination. Here it comes from.
I think it's a good set. I mean, what you just described, in Alex, is certainly, I guess, a way forward. But in general, it also depends. When you're designing a certain headset, you have to fit components around, and there can be different arrangements. As you obviously know, the light engine can go at the top or on the side. So all of those factors actually need to be taken into account to answer your question, in my opinion.
I think we have a question from Yuya team. Yeah.
Hi.
Hi, Asaf. Hi.
Hi, Sana. I wanted to ask Arseny. We are Olga and Asaf from Joy team. First of all, thank you for mentioning us and the webinar that we gave. It's nice to hear that it was beneficial and people got ideas. I have a question regarding maybe you can thought about making custom designs of your waveguides for not your general products, but custom design per specific requirements, like different field of view or different eyebox, or something that is not general, but something more specific, very non-common requirements or non-common designs.
Hi, Olga. Thanks for your question. We can certainly do this. I mean, the short answer, yes, but there should be a business case for this, obviously.
Very good.
Okay,
so
thank you.
Thank you. I think I see Peter is in the room, Jose. Would you like to introduce us to your friend?
I can repeat the whole thing, but it's already in YouTube, so no need for that. All I want to say is that I am so happy for having Bosch Sensortec in the room. I really wanted all of us to be at Bosch. It was going to be the plan to have a present meeting at Bosch for the beginning of the year, but it's not possible. We do it like this. Thank you very much, Peter Ostertag. Thank you for representing Bosch Sensortec at this meeting. The floor and the attention of everyone goes to Bosch, goes to you.
Okay, thank you very much. I'm really, let me say, I'm sorry for messing up. I'm thinking it's within our network, so I used Zoom before, but no, unfortunately, I cannot place video. Jose, I think I sent you the presentation.
Yes, we are ready to rock.
Probably. Okay, then I can see your screen at least, if you could share it, and then I can just step through it. So
we are getting your slides up, so just for 1 second. Sana?
Yes, 1 second.
This is one of the beauties of doing things live. Peter,
Yeah.
we are going to have this meeting eventually. We never cancel anything. We only postpone. As soon as we manage to know when this meeting is going to be, Peter, you and me, we need to find a really, really good restaurant to bring all this community to a fantastic dinner. I really can't wait
we
for
will
that.
do so. Yeah, and unfortunately, we were not able to host this meeting now with all, let me say, the COVID-19 topics. So we also prepared on our side for doing that, and I wished really we could do it. Yeah, but unfortunately, it was not able.
Peter, your slides are up. You're ready to rock.
Perfect. Then yeah, please probably step to the first slide. So who we are, Bosch Sensortec. Yeah, so I think Bosch is already known. Bosch Sensortec probably not so much. So we are the MEMS pioneer. That means we started 1995 with the first MEMS production. We have, let me say, done now over 10 billion of MEMS sensors produced, and we do it 100% in-house. So, but we are not just doing sensors, we are doing also the projection units for that, based on our MEMS technology. And of course, we have, in the meanwhile, over 7 years experience in this laser projection module. Now also, so providing the whole projection unit. And what is all about this is, if you step to the next slide, please. So, yes, one fast, but okay. Normally we see a bicycle race or bicycle outside, which and you cannot see probably you cannot see, or you see where you are, but you cannot probably see how far you have to go and what is that. And therefore, we feel that let me say, enriching the environment by information like bicycling, navigation, messaging is worth it. And we are also excited, step please to the next slide, that we can provide, and I heard when I struggled to dial in the numbers, the topics Waveguide, but we will also provide a solution for retinal scan. We feel that both solutions in the market are important and fit to probably different use cases. But the best about our thing is that we can provide and fit to both worlds. And this is, in my opinion, something really exciting. For us, was important for both that our module will support you in doing outdoor sports activity, navigation, and far beyond in business life with notification and all the stuff into that. And you talked before also about the topic iBox. Yes, we need a big iBox in that. And Waveguide, I think Waveguide systems are pretty much prepared for this, and the retinal scan will also come to that. So I think we launched, probably you know it, a first system set up at the CES last year with the retinal scan, of course, not with this big prawn and iBox. And this is something where, of course, we are working at. Compared with all technologies on the market, we feel, of course, that the laser projector brings in an outstanding visibility. Why? Because we just project the information which can be seen. There is no backlight, needs nothing in between. And this is exact for the night ops. It's really necessary. And of course, we can provide infinitive contrast. We are pushing, of course, can you please stay? Yeah, we are pushing, of course, let me say, the power to really low consumption. And of course, the size is key also for the weight. So our, let me say, offer to the market is that we provide an easy to integrate low power projection module for consumer and industries for near eye display. Of course, we cannot do everything on our own, and then please step to the next slide. Therefore, of course, we are looking every time on low power diodes, at present probably lower than 1 milliwatt of optical output power. And this is also to, let me say, to optimize still the power consumption of the whole system. Since we have a fast development, fast growing demands from the market, of course, we need also to react in our development circles very fast. And therefore, it would be nice to have partners for fast prototyping of optical components, which is for us the optical components more in the freeform adjustable focus lenses. Then, of course, every time where partners could support us in materials for projection module carriers, this might be very beneficial. And last but not least, the projection unit is nothing without the right combiner, even if it's hologram in lens or waveguide combiners. So that's in really short for my first presentation to you. And now I'm available also for
Oh my God, Peter,
side.
that was fantastic. I really love this slide. You are looking for cooperations in things that actually Epix excels. This is really, truly great. You know what we're going to do? We're going to go to these 4 bullet points and find you potential partners. I'm going to start with the first one. You are looking for low power laser diodes with less than 1 milliwatt of power. I love VCSELs. Everybody knows this. And nobody loves VCSELs more than me. But the second in command is David Cheskis from Lumentum. And I think he's in the room. David?
Hello, yes. Good afternoon.
Hello, David. How are you doing? It's good to see you. It is 3:30 in the afternoon over here. What time is it for you?
It's 9:30 in the morning. So
good morning, David. So you saw the presentation from Bosch. Anything resonated there? Any potential room for cooperation?
Yeah, look, I'm very interested. We've got obviously a wide range of laser diodes, both for world-facing as well as front-facing kind of applications, and these wearables line up right with that. So I'm very interested to understand what the requirements are and what we can provide for that. And we've got a full range, as you know, and to me, it's an exciting opportunity of converging the display technology with the sensing technology. So,
Peter, when it comes to the light sources, are you looking for VCSELs? Are you looking for VCSEL arrays? Are you looking for any other potential technology? How does the system look like a little bit?
So I think VCSEL would be perfect. And even if we have in the red, green, and blue color, I would be very happy to look at this. Mainly we have single mode lasers in use so far, and this comes also from the combining technology. So that would be really good to look into that. So even if it's single mode laser or VCSELs, we are really interested in.
Peter, in these kind of meetings, David, I'm sure you're going to want a one-on-one introduction on this and follow up, and I will be more than happy doing so. Peter, in a meeting like this, first I go to David Cheskis to Lumentum, and then I go to one of the people that I love the most in the freeform optics domain. I go to Rochester, New York, and I go to Jessica de Grote Nelson. Please switch off NBC or ABC channel. I know it's a big day for the US. Jessica, how are you doing?
Very good. Thank you for having me. And yes, well, good morning, good afternoon, everyone. And yeah, I was very excited to see that you're interested in fast prototype freeform optics. And that is definitely something that I'd love to know more about what your needs are in that realm, because this is something we specialize in. And you may have seen our tagline, prototype optics in 1 week. So we'd be happy to talk more about that and talk about freeform capabilities.
Okay. Perfect, Jessica. I think Jose will probably link or exchange the contacts.
That would be fantastic. Yes.
Yeah. Perfect.
Jessica, I was really impressed when I saw this 1 week whole production line. Could you tell us a bit what happens in that week? Maybe in a couple of bullet points, so we can know that it's for real. It's 1 week.
Yeah, so we do. All of the optics we make are custom, and so it comes if an order comes in and a customer needs it in 1 week, we go through a very quick process engineering cycle to make sure that we can make it, and we have the processes and metrology in order to be able to verify it. And hopefully we have material on hand. That is a key thing. And once we have material, we hit the ground running. Grind, polish, measure, coat if necessary, and then ship it to our customer.
Jessica, thank you very, very much for being here, and please stay with us. And I'm going to go now to a question in the chat, because we have a question from Synopsis, and I love Synopsis. So Maribon, what's on your mind?
Yes, so it was really nice presentation, and I was wondering, you told us about complementarity on the retina scan techniques and waveguide.
Where you have, let me say, better implementation with a retinal scan than with a waveguide. So I think this are for me the different. I would not differ. Let me say that the retinal scan is just for consumer, or that the waveguide is just for professional use. I think it depends more on the use case than on the market, finally, from my perspective.
Okay, thanks.
Thank you very much, Maribon. We continue, Peter. This is going to be spectacular. I'm going to go now to VDL. For those who live in the Netherlands like me, we love these 3 letters when they come together. Jos, thank you very much for being with us. What's on your mind?
Well, this is Jos de Klerk from VDL ETG. And I wonder how those patterns are being made in those glasses. I saw those structures are probably gratings, fiber brack gratings. And I guess you need equipment to produce those gratings in those glasses. And I guess there is a need for high precision, fast equipment to produce those structures in the glasses. And this is something my company can probably provide.
Of course, there are structures in here, and there's also a certain, let me say, precise operation. So I think it might be interesting also to come with you in contact and probably exchange the needs for that, and or you can also, let me say, show to us what you can offer in order that we figure it out if there's a fit for that.
Okay.
So in principle, I think we can say so far that it is a kind of foil, which is more or less an optical mirror.
Right. Okay. Let's make some contact then after this meeting.
Yep. Thank you well, Jos. Goedemiddag. And I want to continue actually, because this is spectacular, the most interesting part of the meeting for me. Peter, in one of the things, one of your bullet points for collaboration, you were talking about new materials for the projection module carrier. Could you specify this a bit more or not? Much better. Look what I'm gonna do. I'm gonna go to Materion. This meeting is spectacular. I'm gonna go to Materion. I'm gonna go to Simon. Simon, thank you very much for joining this meeting from Materion. For those of you who don't know Materion, this is one of the leading R&D on advanced materials. Simon, did you see the presentation from Bosch? Is there a potential room for cooperation?
I did, Jose, and thank you very much for allowing us to present here. And good afternoon and good evening to everyone. Yeah, for the actual projector module, I'm just interested to know, does this actually house the laser diode? The reason I ask is actually we are working with another Bosch division for a metallized, what we call a cap. And in that, it's going to be a hermetic assembly with a window, and the laser diode sits within that cap. So my question is it actually to house the laser diode? So we are manufacturing materials for hermetic assembly.
There's a clear answer, yes, and that's the same team. So it's part of my product.
Okay.
Let me say, yeah, it's within the Bosch world. It's the manufacturing design house who is doing that for us. Yes, in principle. So Jose, also coming back to the question, what is the need? So the need is every time for material which is really lightweight, stable, where we have really flat surface that can be, let me say, produced and worked with in a very precise way.
Lightweight, stable, cheap, injection molded,
Yeah,
most
cheap.
likely, of course.
Cheap, of course. No, joking. But yeah, I think it must be, of course, stable according to temperature. So there should be not much deformation with temperature and all the things. So very stable. That would be the need there.
Peter, I love this discussion, so I cannot stop it. I'm going to continue it. I'm going to go to Aachen, to a common friend of us. I'm going to go to the company Aixentep, Tobias Muller. Hey, Tobias, Happy New Year. Tobias
Hello,
Muller is here with us. Tobias, you saw the presentation from Bosch. We are talking about lasers, optics, materials for the production, micro displays. We had to put all this together. Did you see the presentation from Bosch? Is there anything you can do with Peter?
Yeah, thanks, Jose. First, and Happy New Year to you. Yeah, Peter and me, we've been discussing in the past already, still at my time at Fraunhofer. Yeah, I think that the challenges which are there in terms of packaging, assembly, and testing in automation context, which is always there for consumer electronics, is, I would say, almost infinite. Creating the light engines, placing lenses right now, not everything is integrated on wafer level. So we have to do some discrete assembly operations. And yeah, that's where we can help from from prototyping to job shop manufacturing, more serious, really until scalable production by installing our equipment at the producing companies itself or at job shop manufacturing for volume production. So yeah, I think, and that's why I also wrote Peter on LinkedIn already. I guess there might be a lot of new things to discuss.
Yes, of course. And Tobias, thank you very much. And sorry for not having answered so far. But I think I will contact you, of course, and we continue the discussion there. I think it's needed.
You had only 5 minutes. I just sent this message, so no worries about not answering.
Yeah, but I saw it, and yeah.
Thank you very much.
Whenever you're there, you need it. Let's discuss, and sure.
Thank you very much, Tobias, and congratulations on that beautiful beer. It looks fantastic. Peter, thank you very much for a great discussion. Stay with us. We are going to come back to you later, but we're going to continue with the program. This Q&A gave me goosebumps. We continue with the program and we go to Jabil and Kasalis. Kasalis is the company that works with Jabil on the active alignment and equipment for the volume production of assembled optoelectronic devices. And of course, as well as Tobias from Aixentec, they see a huge market for this. Aaron Israelski, thank you very much for being with us. Cześć, the floor and the attention of everyone goes to Jabil, goes to Aaron, goes to you.
Thank you very much. How is everybody? Thank you for having us. We're happy to be here and look forward to sharing some information related to active alignment for AR devices. So just to level set with everybody and make sure we're all on the same page, let's start off by defining what is active alignment. Active alignment is a closed-loop precision assembly technique that uses a device's functional output as feedback in order to determine the optimal relative positioning of components during assembly. So what this means is that as compared to passive placement techniques where you use either machine vision or mechanical registration features, we're actually turning on the device, seeing what it's doing, and adjusting the components relative to one another in order to optimize performance. So in the field of AR, VR, MR, there's several manufacturing challenges that can be overcome by using active alignment. First and foremost is the overall complexity. And while everyone's final product architecture is somewhat different, what is common is that there's many, many optical subsystems that have to come together very precisely in order to yield a high quality unit. So by having well-controlled and very accurate assembly techniques at each of these steps, you're able to go end to end in order to yield quality units at the end of your manufacturing line. Another challenge in general is that there's many different quality metrics that must be simultaneously optimized in order to generate a quality, high-performing device. So it's not good enough just to look for focus. It's not good enough just to look for pointing. It's not good enough to look for contrast. You have to combine all of these functional parameters together in order to, we have to optimize all of these together in order to produce a device that provides a enjoyable experience to the consumer. Another challenge that we see across many of the architectures is what we call binocular alignment. So we have two eyes, fortunately, and you want to align the image seen by the user into both eyes simultaneously. And if you don't account for binocular alignment, both in your design and your assembly process, you have some adverse effects. One of the main differentiators of the AR devices on the market is field of view, right? Everybody wants a wider field of view. And if you are cross-eyed, because you're not controlling the pointing of your projection during assembly, you end up giving away pixels, field of view, and display area. And this is the exact opposite of what we're all trying to do. We want to maximize the amount of image coming into the user's eye and enhance the experience seen by the consumer. So by controlling the alignment of both the eyes relative to one another, relative to other datums, we're able to take full advantage of the hardware architecture that went into the design and utilize the full display area and capitalize on the available field of view. Another obvious challenge to pretty much everything, but specific to this market, or especially pertinent to this market, is cost. These are high technology devices. They have high BOM costs. It's kind of unavoidable. You're not building an AR wearable for $5, obviously. And the user is expecting high performance. And so how do we balance cost and performance? And the best way to do that, at least on the manufacturing side, is by having a high yield process that generates high quality devices with high throughput. So active alignment is a means of, again, providing that end-to-end process control for yield and quality. And through proper automation techniques, we can offer high yield, high throughput production systems for AR devices. And lastly, there's challenges in manufacturing for test because there are all of these steps that go into building up a final device. It's important to have good testing in line and at the end of your line to ensure that you're not passing poor performing modules into your line. So the challenge here is that unlike things like, say, a camera module, there aren't standard test methodologies, standard testers that you can buy off the shelf. So depending on your architecture, depending on your performance trade-offs, we can tailor testers around your requirements to ensure that we're getting good end-to-end quality through your whole manufacturing line. In terms of different ways that active alignment can be applied towards this technology, there's two primary buckets. There's the image projection, which provides the user experience, and then there's the sensors that go into the device as well. And these can be for room detection, object detection, 3D mapping of a space or an object. And all of these different optical sensors and optical modules will require precision assembly that can benefit from active alignment. So in the case of image projection, again, there's different architectures, so some may or may not apply to your specific device, but there's the need for alignment of the projection optics. There is the need to obviously align the display, whether it's a LCOS, OLED, or other micro display. There's a need, again, depending on architecture, for illumination alignment. This could be an RGB projector to a MEMS. This could be providing light, into another projection subsystem. There could also be a need for waveguide to waveguide alignment, for waveguide-based wearables, where you need to align the layers of the waveguide relative to one another in order to ensure that you have good and efficient coupling. Lastly, there's the need for taking your projection engine and aligning it to the rest of your optics assembly in the waveguide. So all of these steps, require micron level or submicron level precision during assembly. And there's tons of tolerance stack up that goes on. And this is where active alignment will help to mitigate these factors and provide higher quality, higher yield devices. On the sensor side, there's camera modules, either single cameras for RGB imaging or stereo cameras. There's laser projectors for depth sensing, time of flight, structured light projectors, and the like. Just to highlight a few of the key capabilities of our active alignment systems. As standard, our systems come equipped with 0.2 micron linear resolution for your XYZ axes and 0.01 degree angular resolution. We have optional stages that we can use for much higher precision. As you can see here, 15 nanometer linear and 10 microradians rotational. We have in-house software and mechanical capabilities to customize our platforms around specific customer requirements. And we'll deliver our machines, with a turnkey process to our customers. So we can use the machines for prototyping, production. We'll work closely with our customers to develop processes in line with their designs to satisfy the requirements that they're looking for in the final device. So I see that I'm running over time here. So I'm gonna skip this last slide and thank everybody very much for your time and attention. And thank you, EPIC, for having us. We hope you found this informative, and please let me know if there's any questions.
Thank you so much. Thank you so much. And I already see a first question from WaveOptics.
Yeah, thank you for the presentation, Aaron. Just a quick question. Do you have already solutions specifically designed for augmented reality waveguides and the active alignment? And what's your experience? Have you done any customer projects already in this field?
We have done alignment of projectors into waveguides. We've done waveguide testing. And we can leverage those capabilities to do the waveguide stacking. So yes, we have worked with several, the leading AR companies out there on these types of technologies. So we'd be more than happy to discuss how we can work together on your applications.
Okay,
Excellent.
Thank you.
Excellent. I'm so optimistic about this meeting. I think there'll be a lot of introduction emails going on for you, Jose, later. Let me, I know you like that. Let me just ask a very relevant question, I think, to the audience here that are very interested in AR industry in general. How can the AR industry ensure the reliability of AR displays, which means ensuring essential contrast and all ambient lights and conditions and eye movement and so on. For this, I would like to hear the thoughts of our friend from INOPTEC. Hello, can you please unmute?
Yes, sure. Hi, Sana.
Hi, Ralf, how are you?
Hi, Jose. Thank you for having me on. Yeah, I'm good. Thank you very much.
I heard you have a good answer to this question. You can just share your screen.
Yeah. I better share my screen so it's easier to explain. Let me put this on full screen. Can you see this?
Yes.
Good. Yeah, last time we spoke about INOPTEC in general, same channel. I explained how we changed the tint so that you can block off ambient light. I do not want to talk about this again because there is already a video about this. So this time I would like to focus on exactly the question you asked: how can the AR industry ensure the readability, especially when it comes to contrast? And this time I would like to contribute a little bit on the head and eye movement issue. For that reason, I created two slides, toggle slides, like before, after, or problem and solution. And I will start here with the common problem, which is probably known by everybody who provides AR glasses. Without any background recognition, if you are in a dimmed room and there's a bright window and a bright day outside, you have a hard time to read the AR content. It's basically not possible against a very bright area. But, and this I meant with toggle slides, now you can suddenly read the content. And the reason for this is INOPTEC has developed a glass with lots of photosensors, and these photosensors can detect the direction of your head. So if your head is pointing towards the window, then the window will automatically get dimmed. So it works in real time, and the contrast will be the same. So this is head direction recognition. However, if somebody is turning his or her head, then accidentally you have again a far too bright window. So you need to do more. And INOPTEC solved again this problem. We call it our Mark II version with an eye tracker. And if this eye tracker is head direction independent, then you have no problem anymore. You could read or you can read the content under any circumstance. So it doesn't matter where the head is turned, the eye tracker, which doesn't mean to be super precise, will ensure that you can always read the content of an AR display. And I'm proud to say that INOPTEC has filed a very important patent with the US Patent Office, and we are currently developing it. And since I'm here on the EPIC channel, I would like to invite all the system providers like Sony, Epson, Vuzix, etc., to engage with us in a talk, and we could have a chat whether we could cooperate. Our ND filters could be applied proximal or distal, so it means before the AR display or behind the AR display. So this is what I wanted to contribute for today, and I hope I could inspire you with this slide, and I have to thank you.
Thank you so much for this very nice presentation. Let me see if we have comments on that. Otherwise, so we have a question that was left. Jose, you're muted.
No, I just responded that my friends from Hoya have a question. Asa.
Oh, yes, go ahead.
Hi, I am from Joya team. Ralf, I have a question about your products, your glasses that you just explained how they work to give high contrast for in different environments. What you're proposing is local dimming solutions?
Say it again, the last bit. Local, a pixelated version, or?
Yeah, what you propose is local dimming of not all the...
Yeah, I think we had a similar question last time. What we do not do is pixelating the LCD, because then your microprocessor is very busy calculating all the different light sources in the background, and then you get stuck with calculation power, and you are continuously calculating far too much. So our solution is much, much easier. We have only one big pixel, which is basically an LCD shutter. And the whole area will be dimmed depending on where you are looking at. This is the task of the eye tracker. And then we have a little tiny camera inside behind the glass. So all what we do is through the lens measurement. We do not have any photosensors outside, which has several advantages. And then we correlate two vectors, the vector of the eye and the vector of the light source. If these both vectors become gradually collinear, then we gradually dim stepless with a resolution of 2 to the power of 16 bits. And then it's a very smooth, but still in real time dimming process. You would love it, I can assure you.
Okay, so I have an additional question about it. Can your element be applied on curved surfaces like spherical visors, or
the shutter speed is, yeah, I got your question, good question. For fashion reasons, the outer curve, I mean, the glass is of course curved, otherwise you would sell something which looks like diving goggles or so. But the active element is actually a flat shutter, and only flat shutters, LCD shutters, can provide the speed you need in the millisecond region. There are curved shutters out there, but they are slow. We are not using them. We are using only the fastest shutters and they are flat, but if you tilt them a little bit, you can accommodate them within a roundish, sexy, fashionable design. This is not a problem, and we did this.
Thank you so much, Ralf. And I
Welcome.
think we have some YouTube questions, Jose, right?
Of course we have questions. But first of all, Asaf, Olga, Joya means jewel in Spanish. When it comes to optical design, you are the jewel of Epic. But we have a question in YouTube for Kasalis, and the question comes from Sarah. And Sarah is wondering, do you think we can define standards in alignment processes one day for eyewear components? Aaron does active alignment, so he doesn't really like alignment marks. But Aaron, do you think together we can define standards when it comes to the assembly for components for eyewear?
I think we're not quite there yet. I think as the technology emerges, I think some standards can come about, which will simplify the manufacturing processes and for equipment manufacturers. But in general, yes, I think that there will be a means to standardize on certain aspects of the submodules that go into the devices.
Aaron, you and me together, we're going to go now to Finland, and we're going to introduce the member number 500. Now we're 660, but they were the member 500, Dispelix. Riku, Rikkola, thank you very much for being with us all the way from beautiful Finland. I love Finland in January. The floor and the attention of everyone goes to the country of sauna parties, goes to Dispelix. The floor is yours.
Thank you, Jose, for the warm introduction and greetings from the snowy and cold Finland. We have maybe minus 2 degrees Celsius at the moment, and last week it was like minus 25. So thank you very much for the introduction. So let me put on the slides. Is it all visible?
It's crystal clear from Dispelix.
Wonderful, wonderful. So hello everybody, nice to be here. My name is Riku, Rikkola. I'm heading PD at Dispelix and especially technology and product integration partnerships. And thank you also for the nice discussion and presentations until now. Maybe to comment a bit regarding those. So Dispelix indeed is working on the single layer waveguides. There is maybe historical reasons for that, but also the thing that we think that at the end, single layer will be the optimal solution. It's the thinnest solution. It's the lightest solution. You actually avoid stacking and aligning. And if you can do this right, you are very close to really enabling the mass market for AR waveguides and wearables. So a few words about Dispelix as a company. We do waveguides, and we have been existing since 2015, and we have background at VTT Technical Research Center of Finland, which we are a spin-out of. And for the 5 years now, we have been developing these single layer waveguides and related technology. We do all the waveguide design in-house with our custom software and algorithms. And then we have, let's say, R&D level capabilities in Finland to serve different customers. For mass manufacturing and for AR level module offering, meaning the project and the waveguide together, we have a partnering approach. And what is maybe special in Dispelix is that many of the companies in this field they have been traditionally working on either LED waveguides or laser-based solutions. So we have both technology platforms covered, and both have their benefits. LED projection maybe has benefit in extreme high field of view, very good image quality. Then laser also is coming strongly, and the biggest benefit at the moment maybe is that you can do really nice form factor. As a company, we have two main product lines, I would say. We have our own DPX waveguides between 30 field of view and 50 field of view. And then we do work with big, large strategic customers and do custom designs for these companies. We are today roughly 60 employees, offices in Finland and US, and growing strongly. And here is actually, this is not a drawing or marketing agency gimmick, but this is an actual picture of a part of our waveguide here. With the single layer, what you can achieve is really the really nice design and form factor. You can be thin, you can be lightweight. And at the end, if you do design the gratings right, you can also have a very, very nice image quality. And as discussed already, we think that at the end, single layer will be the optimal solution from a manufacturing point of view. You don't need to fabricate multiple waveguides, stack them and align them. But if you do it right once, it's ready to go. And also what we have tried to do, we have tried to be compatible with as many projector technologies as possible. We started with DLP and also now have LCOS, micro-LED and laser covered. And what can be achieved, and this is an actual prototype of Dispelix, which we actually presented at the CES event last week. So this prototype here includes Dispelix waveguides and a partner's projection unit. And roughly this form factor is Dispelix target for the eyeglasses product segment. So this is now what can be achieved, and I personally think, and many of our customers and partners think, that this already looks pretty nice. And regarding the ask, the shopping list or wish list, so this is what we are looking for in a broad scale. So we are always interested in ultra small micro displays and projectors. We are also interested in very, very high field of view projectors, for example. Then, as the waveguide is our main business, we are always studying ultra high refractive index glass, other materials, resins and coatings. And as we are doing many demonstrations with our partners and customers, and we want to demonstrate that what we are capable of. So all technologies that can contribute to creating a prototypes like these and small series production for the components in glasses. So those are really valuable and interesting to us. So briefly, this is Dispelix and still cold in Finland, and I'm happy to welcome any questions you might have. Thank you.
Thank you very much. I am amazed. I love this slide, actually very well designed with the beautiful glasses. By the way, they look fantastic, of course. And looking for potential cooperations, you knock at the right door. So let's find you some of these cooperations. Let's try our best to find you some partners here. And I would like to first, let's go through the entire supply chain. Everybody should be ready. Everybody's full of energy. So let me start for Christine from EVG. She looks very excited. I think she knew I was going to come to her. Christine, thank you very much for being with us today. These people are looking for lenses in volume production. I know you've been working with, I don't know if I can say, but with one of the speakers today, and you have actually done a fantastic job in this field. You saw the presentation from Riku. This is one of the future gazelles in EPIC. How can you help them?
Thanks for asking me. Of course we can help them. We can help them a lot with manufacturing of the waveguides. But I think the question from Dispelix was more about the materials here, like what is an ultra high refractive index materials? I mean, what I've seen meantime in the supply chain is high refractive materials in terms of glasses up to 2. Dispelix, Riku, would up to 2, would 2.0 be something you're looking at? Or because what we can offer you, we know that we can process such wafers, so we don't see any problem in imprinting a 1.9 or a 1.8 or a 2.0. It will be all the same. But the supply chain, I think the bottleneck is more where we get the materials.
That might be the case. Anyhow, this is what we are studying and interested in at the moment, and we have of course things running at Dispelix using the existing technologies that are available today. But we are always scouting for new solutions that would enable us to take the next step. So this was the ask, motivation behind the ask.
Thank you very much, Christine. I can't wait to travel again and go to Florian and Ing. It's really one of my favorite places in this continent. And I'm going to go now to one company who's going to help you with the coating side. So we have somebody from Optics Balcers in the room. John, how are you doing today? It's good to see you. You saw the presentation from Riku. We all want to help Dispelix. How can you help them?
Hello, everyone. It's good to be back again. A lot of familiar faces. Yeah, I had actually talks with Riku. It's been a while ago now, last time when we still could meet in person. And well, turns out, from my understanding still, the coatings on the waveguide itself, they're pretty simple, right? Which you can get them anywhere close to the factory. But I think our strengths and where we have developed ourselves now for the AR community is more the components inside the light engines. And so actually, we've seen WaveOptics also makes light engines with partners or partly their own. Dispelix makes light engines, Bosch makes light engines. So I think one thing I want to say, if you need small components, PBS cubes, or we are looking now into X cubes also, which are, of course, in combination with micro-LEDs, can become very interesting. Unfortunately, the manufacturing of X cubes, so X cube is like a X-shaped, right? RGB combiner in a cube. These are topics that we have on our roadmap and are looking into. And if people are interested or willing to maybe start an adventure that might not yield samples next week, but maybe step by step get somewhere to introduce the next generation of light engines, I mean, then we are open for that, and we are actually also looking for partners.
Thank you very much, John and Riku. Don't worry, because I continue. I'm going to go to Jena because I love the capital of optics, because Simon also wants to collaborate. Simon from Jabil. Oh my God, from Jabil. Simon, how can you help Dispelix?
Hi, Jose, how are you doing?
Doing great.
I only can offer to support Dispelix. So Jabil Optics holds a lot of expertise in assembling entire devices, AR/VR devices. So we can support companies already in early stage, doing prototyping all the way through to industrialization and mass manufacturing of such devices. So at early stage, we can engage our supply chain of more than 17,000 qualified vendors to come up with, let's say, parts in lower quantities. We do not necessarily have to do them ourselves, but we also have injection molding capabilities in-house. We have different capabilities that match the requirements of such products in a lot of details, including, of course, the manufacturing of the devices.
If you ever are in Jena, for all of you, you have to see the showroom and, of course, the visit Simon, but the showroom of Jabil, where they manufacture the GoPro camera. I got goosebumps last time I was there. I'm going to continue with this round. I love doing this. So this is the picture, the shopping list of Dispelix. I'm going to go to Munchen. I'm going to go to Patrick from Delo. When you see this picture, Patrick, what comes to mind?
And if I look at this picture, Jose, thank you for giving me this opportunity here. I'm thinking of all the solutions we can offer. I mean, we're a material supplier where we can supply materials for packaging, for assembling. So assembling micro projectors, micro displays into these frames, active alignment of waveguides, of lens assemblies. That's the materials we offer. We can tune them, we can modify them for the specific needs. We can make them black, we can make them transparent. So whatever you need, come to us. We have a huge catalog of modifications available and materials available that we can offer to the whole supply chain. If it's active alignment, if it's passive alignment, small, big, speakers, lenses.
Patrick, since you joined Epic, I have introduced you to many companies, and all of them keep thanking me for the introduction. You have been a really, really good Epic player. I call that. I continue with this. I want to go to MICLEDI, and the reason why I want to go to MICLEDI, they already spoke, but I got goosebumps, and this is one of the ones to watch. MICLEDI, all the way from Leuven, all the way from Belgium. I want to ask you, because I know you have a slide, but first I want to ask you, do you think you can help Dispelix?
Well, thank you, Jose. MicLEDI is focusing on the microdisplay, micro-LED, microdisplay volumes or modules. And actually, I think the two keywords of ours, ultra small volume and large field of view and high performance micro-LED displays. This is what we do. That's our, product.
Happy to talk more.
I know that we can hear a little bit more because Sana told me he has a slide. He has a slide. Don't be shy. Show us a slide.
I can show you one slide, yes, to follow on exactly on this request, I think. So that's the proposition of MicLEDI micro-LED technology. And as you see here, it goes really about some of the common pain points of AR, namely the volume of the component and the image quality. Field of view we take as part of the image quality. And on the left-hand side is what we start with today in the commercial AR headsets on the market. So a 3D components, projection components, LCOS, DLP, this type of technologies. And on the right-hand side is our micro-LED product vision. So 2 points I think important about MicLEDI business model. We are fabless manufacturing, so we are working with external CMOS foundries to create these components, to manufacture them. And the end product of MicLEDI is the microdisplay. So we are offering it in a B2B mode to the headset makers. We don't do the headset, we don't do the waveguide. This is the place where we look for collaboration. We have one very nice display component. That's our competence.
Alexander, I am very, very impressed with MicLEDI. I already told you that in private, but I'm happy to say that in public. I'm really, really impressed with this company. The future is very, very bright, very, very bright for you. We have a question from Dynasil. Nirmal, what's on your mind? I'll have you muted, which is, by the way, the sentence of 2020. You are muted.
Sorry. Yes. Thank you so much, Jose. So one of the things I wanted to explore is Riku EMF. I represent EMF, which is one of the 5 Dynasil companies. And we are a pioneer in thin film coatings, having started that first company in the US back in 1936. And we offer a portfolio of precision, custom, and high volume coatings, including for different substrates, including plastics as well. We do a lot of coatings for face shields for first responders. We do a lot of coatings for a head-up display in automobiles as well. So maybe that there's an opportunity there for us to continue this conversation. Yeah, wonderful. Let's be in touch. Thank you. Thank you.
Riku, as you can see, you are going to have a lot of introductions. There's the next one, you know him very, very well, but the rest don't. I'm going to go to one of the companies that in the coatings is excelling. I stay in Finland, but I want to hear from Jukka from Incron. Jukka, you know how much I love your company. This is clear. This is the meeting for you. What can you do for the others? Dispelix knows you very well. What can you do for the others?
Yeah, let me see. Thank you for the opportunity to show 2 slides. So I think that is my slide okay now?
It's crystal clear.
Okay. Yeah, I think that somebody mentioned that it's a simple thing to make the coatings, but I'm not sure if I fully can agree with that. But let me just quickly run through what we can offer for the AR class market. So what we are pretty much concentrating in is to design our own high refractive index coatings for nano imprinting. There's a couple of pictures in there. So we are currently already exceeding quite nicely 1.9, getting closer to a 2.0, and we have a very good processability. But then also we have a brand new product which is high refractive index optical absorbing black. So we've seen that we can reduce the backscattering on the high refractive substrates by 96% compared to standard black materials. So I think that this kind of a material, it's not good, or not only good for the diffractive gratings, but possibly also for holographic type of the AR glasses. And then we have a supporting gap filling, totally particle-free, low refractive index material starting from a refractive index of 1.1. And in order to get better and better, we have purchased an EVG nano imprinting tool in-house, which we are running now quite a bit, so that we can quickly optimize our own materials and also, if needed, help some of our customers. There's just a couple example nano imprints with a basic test mold in there. So materials, coatings, that's what we can offer for the AR market.
Thank you very much, Jukka. As you can see, this evolution towards wafer level micro-optics, sometimes wafer level freeform micro-optics. Do you see a challenge for applying the coatings? Is nano-imprint lithography the right solution for this?
For AR?
Yes.
I strongly believe that this is the way how it's going to move. I'm betting that at the end, the diffractive optics will be the winner, but of course we also want to be able to serve the holographic optics as well.
Jukka, DOE is the success story of Europe, and you have been with your coatings playing a huge role there. Congratulations on what you're doing with Incron. Really, congratulations. I can't wait anymore. We all are waiting for this. The next presentation is from Oculabis. They are bringing augmented reality to the industrial manufacturing world, and they came here to Epic looking for partners. The floor and the attention of everyone, it is 4:21 in the Netherlands, goes to Martin Plutz, founder and managing director of Oculabis. The floor and the attention of everyone goes to you.
Yes, hello. I hope you can hear and see me.
Crystal clear.
All right, then thanks for the invitation. And I'm a little bit of an expert here, I would say, because I will talk about more from a solution provider perspective, not going too much into technical details of hardware development. So we're a software development company using smart glasses. And of course, we already have gained a lot of experience, what are industrial requirements regarding those devices. Yeah, but before that, let me give you some backgrounds on us. Like Exemtech, we're also a spin-off of Fraunhofer from Aachen. We started in 2016. We've now grown to 60 employees, a completely bootstrapped company, and yeah, going quite well, I would say. And that all started with that little picture here. Back in the institute, I saw those former colleagues trying to fix a problem with that machine here. And as you can see, they had like 2 smartphones doing wild gestures. And what this shows that there is actually a missing problem, a missing process when it comes to troubleshooting machinery and equipment. Of course, that causes downtimes, travel costs, travel time. Now in times of COVID-19, we cannot travel anymore. So the benefits become more and more obvious. And yeah, that's and back in that time in 2015, we got a pair of Google glasses in our hands. And so we had that problem and having an idea of a solution and bringing that together and forming our vision. And that looks like this. So to have a well-defined process of how we interact with machinery and equipment, not only for troubleshooting, but also for planned processes like maintenance operations and things like that. And as you can already see on this picture, on our vision picture, there are those glasses, but you also see a tablet and a smartphone, which we've learned quite fast in the beginning that those glasses are kind of a technology push for lots of companies who intend to use those glasses. But in the end, it's not about hardware. It's in the end about the solution and the processes you create on that. So that's why it's also for us now very important to be device agnostic. Those glasses are an option that some of our customers are using, but in the end, it's not about the glasses in the end. Yeah, and from our solution, as you can see here, there are different aspects in the solution, like having these remote expert functionalities, but also having augmented reality features, like having those X-ray view inside of a machine to visualize components, to provide step-by-step guidance for the operator. and also combining IoT features, which is something we are working on currently, to also display real-time data of machinery and equipment in those augmented reality views. Yeah, and bringing this all together to one solution to help employees and machine operators, yeah, to work on their problems in a better way. That's just a summary of our modules, basically. But let me just jump to the slides of the glasses, which I brought here as a short summary, as an overview of what kind of glasses exist. Of course, you're also quite experts in this area, so I don't need to really summarize the different aspects here. So we're not doing virtual reality, by the way. So we only focus on real world interaction. So that's why this is out of scope. But as you probably also know, that has been quite a hype topic over the last years. But it's also showing that there were some players like Dakri or ODG or Meta that disappeared after time, and you also see that there's a lot of venture capital that was burned there. So it actually shows different things. First of all, it's not that easy to build an industrial grade pair of smart glasses to fulfill the requirements that are needed in industrial use cases like robustness, performance, and things like that. And what remains here, as you probably also know, is big players like Microsoft, Epson, or Google that have the financial power also to really go on with that topic. And what also remains is RealWear, that is the device that is mostly being used by our end customers if they decide for glasses. Then it's in 99% it's a RealWear glass. Because that's the only device that really meets the industrial requirements of smart glasses. And we also have some customers. I mean, in the end, using smart glasses is about having your hands free in industrial scenarios. And this could also be achieved by this low budget solution. That's just a smartphone holder that you wrap around your neck and you put your smartphone in there. So we also have some customers who are using this because they realized, okay, they see these smart glasses and it's being perceived as an innovation. In the end, it's about being hands-free. And it also brings some disadvantages like taking care of the glass, where it's being stored, that always needs to be charged and things like this. So in the end, it can sometimes also be a very down-to-earth solution. Yeah, and to sum this up, from our experience over the last 5 years, the most important requirements for a pair of smart glasses is that it needs to be robust for industrial grade scenarios. It needs to be performant, like having a good camera, having a good battery lifetime and things like this. And of course, in the end, it's a human-centered technology that needs to provide a high wearing comfort to the people who are wearing it. And bringing this all together and creating a device that fulfills all these requirements is not that easy. And that's I'm also very curious about your developments, like we've already heard. And if you have some prototypes or you need someone who tests it, I'm a good person for doing that, I think, because first of all, we're interested in cooperating with new hardware suppliers that might have even better devices, and that would be my offer. Yeah, but like I said, in the end, it's not about hardware or smart glasses. In the end, it's about the software and the solutions and the new processes you create on it. And our customers typically increase their machine availabilities with our solution, reduce travel costs and travel times, but also create new digital business models in service. So not only selling a machine, but also selling those services that can be created on top of our solutions. And yeah, these remote troubleshooting scenarios, this classical scenario that you always have in mind, but there are also other scenarios like acceptance testings, commissioning, or you might support your service partners all over the world. We have about 200 customers that are splitting up in 2 groups. On the one hand side, it's machine manufacturers like Trumpf or others. And on the other side, it's big manufacturing companies who are using it for internal purposes, for typically connecting their global manufacturing plants and using the benefits in internal applications. Yeah, and that's it from my side. I'm looking forward to your questions now. Thank you very much.
Thank you so much, Martin, for this overview of the applications and for being open to collaboration on testing. That's very important at this level, I think, for this technology. And I would like to see if there is first questions in the room that we would like to take. Otherwise, I heard there is some questions on YouTube, right, Jose?
There's a lot of questions in YouTube. Oh my God, there's a lot of questions in YouTube. The first one is coming to the person who just spoke, to Oculavis. We have a person, Dick de Man from Topic.nl in the Netherlands. He's wondering, do you have some information about the applicability in the medical part? Do you have some ideas or some potential interest to enter the medical industry?
Yes, of course, we are open to that. For now, we don't have customers there, but it's mainly not because there are no use cases. It's mainly because we're not focusing this area. But it could probably be easily adopted to those fields of applications. So of course they can just contact me, and I'm open to have a deeper discussion on that.
Martin, the person who asked the question is super nice, so I'm more than happy to make the introduction. We continue with the questions in YouTube. The second question goes to WaveOptics, and they're asking the $1 million question. Arseny, how do you deal with ghost stray light?
Thanks for the question, Jose. I'm not sure I can reveal all tricks. But and I will not. Yes, but in general, you can deal with it with a smart design of the whole optical system, because you've got your light engine part, you've got your waveguide, and if you know where the straight light is coming from, the source or potential source of it, you can design it in the way that it doesn't distort the user image. But I guess that's all I can say.
That's quite a lot, actually. But yes, I'm gonna go to the next question. The next question comes from SUS MicroOptics, Wilfred Knoll, and he's asking Dispelix, Riku, how do you couple the light in and out of the waveguide?
How do we couple in and out?
Yes.
By using diffractive gratings.
I think that's exactly what he wanted to hear. Thank you very much. And we go to the next question. The next question comes from Israel. Yuval Ophir, he used to work for Elbit. Now he's preparing his own startup, and he's asking Patrick from Delo, would be great to hear about ultra low refractive index adhesives and coatings. How is Delo dealing with when people are asking for ultra low refractive index materials?
So ultra low is very interesting. We get a lot of questions on that. I think there's a lot of interest getting ultra low. I think also Jukka from Incron had that on his slides for materials at least. Interesting part for the ultra low adhesives is really the reliability. So reliability really needs to be matched to the application, and then it's a weighing process. You need to adjust the index to the other requirements you have. So you will reach out and we can discuss it more in detail, your application. I think you have my contact.
Fantastic, Patrick. I'm going to go now to Ralf from INOPTEC. By the way, Ralf, there's a lot of compliments for you in YouTube channel, so thank you very much for fantastic presentation. Ralf, you have a question from Oculavis. What's on your mind?
Yes, just a quick one. I was impressed by the slide where you showed us all your customers, and I'm wondering if one of your customers have ever said, we have a demand to have an eye tracker, so that the instructor on the other side might say, hey, you're looking at the wrong part. Go to the left, go to the right. Have you heard anything about this? Is there a demand for eye trackers?
Not really, I would say. I mean, of course, it could be beneficial for those scenarios. If that would be a pair of smart glasses, that would be very good for all other requirements, like being very robust, like having a very good camera. And that would go on top. Of course, that would be perceived as a nice innovation, I would say, but it's not a core requirement, I would say.
Okay, yeah, great, thanks.
Thank you very much, Ralf, for asking this question, because we have See-Through Technologies, Piotr Barczak, in the room. Piotr, are you there? Let me come back to you over the next Q&A. We discussed already offline, and he's one of the companies that we have in the eye tracking sector. Dr. Amairi-Pyka, back to you.
Thank you so much. So the question now is rather going back to the manufacturing, and I would like to ask CSEM, Guillaume from CSEM, to show us a little what they do. Guillaume? Hello? Hello? Guillaume?
Hello, can you hear me?
Guillaume?
Yes, can you hear
Yes.
me? This
Yeah.
time, sorry, it took a while. So I will share a slide, it will be easier.
Yeah, can you please share your slides?
Here it is. So I want to share a recent development that we made on fabrication and to show what can be done just putting things together which are now available today in Europe. So with nice material from Incon, with a refractive index of 1.93 in the green, another high refractive index glass, we can imprint for a single color a large field of view of a bit more than 60 degrees here. So imprinting gratings on this high refractive index glass. And we can achieve very high diffraction efficiency and very high coupling efficiency. And the materials and the glasses are very good. So this opens the range for indeed very lightweight and very large field of view smart glasses in the near future. If you have any questions, I can of course answer that.
Thank you so much, Guillaume, for telling us what the CSEM is doing. And let me see now if we don't have another question in this regards. Let me see if we have any other questions. Otherwise, I would like to hear from our next speaker, Marie-Vonne.
Yes, hello.
Marie-Vonne, how do you find the meeting so far?
Really interesting. I'm so glad to join you today. So it's the perfect audience for me. So thank you so much to have to give me the opportunity to talk about a bit of one of the major challenge for all the designers that I have at the front of me today. It's optical design, and on my side, I want to cover a part of this challenge on the simulation part and what we can do, what we can offer to our users from Synopsys. So today, yes, I will cover how our software and especially the multi-domain optical simulation part included in our software can help for augmented and virtual reality. Just before to move to the subject, a quick announcement. Maybe some of you know me. I was from LightTech, so 2 months ago now. So yesterday it was 2 months anniversary for me at Synopsys. So 2 months ago we were acquired by Synopsys. We know really well this company. It's really well known for EDA software, but we were working with Synopsys since a long time for optical design software. And at LightTech, we had our own expertise. It was on measurement services, so how to characterize optical surface. And it's one of the technologies that Synopsys was interested in. So that's the reason why it's a natural acquisition, and we join in a nice way this really beautiful company. Let's continue of the business of Synopsys and especially the optical design part of this company. So Synopsys has a large, broad simulation portfolio, and on the optical side, we have different type of software. We have some software based on ray tracing. A lot of people in today joining this talk are really familiar with ray tracing software. On our side, we have one solution called Code5 for imaging system. Then we have also light tools, really well known for illumination design, and I will be focused on that part. And just for your information, we have also one solution called Licit Shape for automotive market, but it's a bit out of the screen for the day. Then we have also solution. We have also solution related to photonics. Parts, so based on Maxwell solver. When you are talking about microstructure, really tiny, small scale structure, in that case, you are pretty aware about that. Ray tracing software doesn't help anymore. So we have to come with another type of techniques, and we have solution in-house to provide a tool to study microscale structure. So let's now talk about the subject of the day. So everybody are dealing with AR/VR design here. We all heard about different type of techniques. So Peter mentioned MEMS, so with a retina scan. And of course, for the MEMS design, there is also some challenge related to the diffraction. But so so let's say I put that on the side for the day. I have only 6 minutes. So for today, I will just focus on what type of solution, of complete solution we have in-house to design waveguide gratings for AR VR application. And of course, it's really important. So that's a really good candidate related to the requirements of this application: low weight, small size, insensitive to vibration, to be usable by the end user. So to come back on the type of design that we can achieve using our software. So let's first start with the complete design is done on using light tools, ray tracing software. But as I told you, ray tracing is not suitable for micro structure. So we have to find a tricks to bring all the diffraction effect into a ray tracing software. And for that, so for all the gratings definitions that we have in the wave plate, we have to bring the definition of the gratings. The gratings is nanoscale, so wavelength scale features. And we have Airsoft to analyze, to design and analyze, to characterize what would be the impact of these gratings. And knowing all the far fields, all the what we call BSDF for the people who are familiar with optical propriety. So Airsoft is able to provide a BSDF, and this BSDF will be implemented into the ray tracing software. To go further for this application, we have also some challenge, and some people mention it, related to the illumination parts. So we have MicroLED. I didn't bring this topic on my discussion, but we have also solution to design the MicroLED itself. So, but it's a bit outside of the discussion. Then we have solution to work on the eye box to implement, to inject light into the wave plates. And that's this eye box, and the quality of the eye box will impact dramatically the final quality of the picture. So that's something that can be done with Code 5, our imaging system design tools. Just to add on the right part of the slide, you have just a quick evaluation of, by having a specific type of gratings, it was a uniform gratings, the type of output that we will have at the front of, on the exit, so on the pupil of the user. But now, so it's of course non-acceptable in terms of uniformity of the picture. But now, by optimizing the definition of the grating, we are able to have a uniform output from the goggles, and to analyze, to optimize the structure, to analyze and check the tolerance that you will have on the alignment. So one subject will come back on the alignment for this type of device. That's something that you can study, simulate through the optical software. So the typical question from EPIC, what we can offer and what we are looking for. So what we can offer, I hope that you had, so you understood that we have a complete design suite, and we are bringing all the technology in terms of optical design, from ray tracing, so Snell-Descartes laws, up to Maxwell solver, and we are bringing all this technology all together to make to follow you on all the challenge that you have at the front of this type of design. And what we are looking for, so it's a bit out of the subject, but still one of the key components for us for accurate optical simulation, it's the optical definition of the materials. So right now, we are looking for collaboration to get some from vendors, customers, users, some idea of samples that would be required in our library of materials. So if you have any materials from glass, plastic, reflective, transmittive materials, so from mechanical parts, you want to have this type of materials defined in the optical design software, please come to us. We will be happy to discuss with you to see the benefits for all our community of users for optical design. Thank you.
So much for this very nice talk and for answering the epic question. You made my job easy here. And let's see if we have first some questions from the room. You can unmute and ask your question. Otherwise, I would like to see the people that are present with us here. We have Jan from Arai. Jan, thank you for joining the meeting. And I'm curious, what do you see interesting for you here?
Anna, yeah, thanks for letting me contribute to the meeting. Well, today I'm technology scouting, and from an integrator's perspective. For example, smart glasses or AR technology could be very interesting for modern viewfinders, for camera viewfinders. So ARRI is a company that offers and manufactures camera systems for cinematography applications. Other things that are interesting are, of course, technology that is developed for the AR market, but that could be also be beneficial for our applications, like in optics, variable ND filter. That's a thing that's interesting to us, or Incron's high index black coatings for example, for stray light control. That's a very significant topic in classical optics as well. Yeah. So.
Thank you so much. Thank you so much for joining the meeting. I think we can continue discussion after this meeting, reaching out again to introduce you to our members that are specialized in this kind of coating and so on. And we have also, I believe in this topic, what is also very interesting is everything related to metrology and inspection, quality control. We have phases in the room, and Yuan, you told me that this meeting is particularly interesting for you. You wanted to join last minute.
Yeah, exactly. It's like, so at Phasix, we provide like optical metrology solutions. So all about the measurements of single lens, but also assembly. Also, because we're able to perform wavefront measurement, we can check the collimation of those RBG illuminators. On the other side is like on the waveguide side. It might have some potential application to be able to qualify the index of refraction distribution directly in the waveguide using quantitative phase imaging cameras that we develop. So all of those discussions are very interesting for me to see like what type of metrology solution Phasix can bring and help all the manufacturers or integrators at the components or at the system level of those AR systems.
Thank you so much, Ian. And let me go back to Marivon. Marivon, we have a question from you, for you from AZO Optics. Why don't you just ask your question? Andre?
Oh, okay, thank you. So nice to see also familiar faces, like someone said before. So it's great to see all of you again. And thanks, Epic, for keeping the momentum going in our industry with this with these conferences. It was really a simple, very stupid question, Marivon. I was wondering what kind of optical parameters you're looking for to define. Is this for new materials or improve on existing materials, or just kind of what were you looking for in that area?
So in order to go to an optical simulation, you need to characterize the material. So of course, you are mentioning refractive index. Of course, it's a part, and dispersion related to the material is important. But in fact, mainly for ray tracing software, the most important thing is surface property. It's what we call BSDF, bidirectional scattering distribution function. It's a kind of far field information. So how the light will be refracted, so in transmission reflection, by the surface of the materials. And that's something that we are really expert to measure on our side. So we have all the bench. But right now, my request is really in terms of our user, what are necessary for them to have access from our software. So we have already a large library of materials available, but we are looking for new materials based on the needs of the market. So that's the reason why any provider, supplier of materials, we would like to see their own materials included in our software. Feel free to come back to us to explain what you have in mind. And so in that way, your materials will be in our library and will be used widely everywhere throughout the world. And of course, the reference related to the materials will be well defined, so people can come back then to you to come with a design and to go for manufacturing.
Okay.
Maribon, but you want the samples themselves? You want people to put the sample in it's very simple. Put the sample in a box and send it to you?
Okay, like, can you measure
the
samples?
Yeah,
exactly.
Yeah, so exactly. So it would be like that. So if we see a clear request for materials, let's say you are a supplier of this plastic, of this glass. So what we will need from you, it's a sample with a certain size. So we have some requests on that. But you will send us your sample. We will make all the measurements, and then it will be provided in our library as an optical property. So it means any designer throughout the world will start to use the property of your own materials to start a design.
This is
test.
Great.
So
look,
that's
Incron, Optics Balsers, Dispelix, all of you. If you want, please send the material, and if you want me to pay for the traveling, for the shipping expenses, I will pay for the shipping expenses, and I will not charge it to Epic. So just please do so, because I love connecting companies. Andres, all the way from Barcelona. How are you?
Thanks,
in a meeting like this one, what can you do for others? What can others do for AZO Optics?
I was hoping to keep a lower profile in this meeting, but
Never.
We're an optical design and engineering company as well, and a systems integrator. So we can provide complete solutions for optical systems that or just in general with product development, where optics is a core part. And we work in industries really high precision, harsh environments like inside of fusion reactors, defense and security, and all the way to even biomedical applications. We design them and also build and assemble high precision optical systems in-house. So we're happy to work with you. We're Code 5 enthusiasts for many years. We work with that product for a long time, and also Zemax as well for a very long time as well. So we're in we can work with both of those things, but like I said, it's more than just the design. It's all the way through the production and assembly of these complex systems.
Andres, I introduced you to many companies, especially for the system engineering of optics into instruments on the medical side, and I got very good feedback of all the introductions. So once again, congratulations on being such a spectacular Epic member. Y un abrazo a Barcelona. I would like to go to Francesco. Ciao, Francesco, from Enea in Italy. I love this R&D center. They're always looking for cooperations. Francesco, we heard from the entire supply chain, from materials all the way to Oculavis in the application side. Do you see some room for cooperation?
Yeah, I hear all the discussion, all the presentation, and I'm just typing a question right now.
I saw that. That's why I preferred you read it.
So exactly. So is to the audience. I didn't see anything about the source of light, let's say, of micro LED or LED. Is there any interest in developing an RGB micro LED or OLED for this virtual reality application? So that's the question for the audience, or for the Dispelix, for example, because they show this beautiful slide that you like very much.
Beautiful question. Riku, can we use standard micro LEDs, or do we need to develop very customized micro LEDs for Dispelix?
So the light that comes from this device, let's say this is glasses, there are colors or monochrome? It's monochrome, or it's
RGB.
Sorry?
All color.
All color. But is that a problem to get some color, or is that a problem to improve the quality of the images? I mean, because we are dealing with we are trying to improve the resolution of our MicroLED. Or it's more a problem of resolution, or it's more problem of intensity of light or brightness of the MicroLED?
I would say at RGB level, maybe brightness is one of the challenges at the moment, also resolution. But those are mainly aspects that are being solved by the companies who are developing the MicroLED panels. We are more caring about taking the image, the lights, and taking that through the waveguide and trying to maintain what the panel and the projector is providing. So from our point of view, maybe one of the main challenges that we are trying to address is color and brightness uniformity, for example, and that closely relates to the waveguide development.
So it's better MicroLED or OLED?
Micro-OLED or MicroLED? Oh, that's the $1 million question.
I would say that MicroLED in this case is better. OLED is always a challenging one because of the brightness.
We have MicroOLED contacting us right now, and they are really excited about that challenge that you place for them. MicroOLED in Grenoble is very, very excited about this market as well. I want to go to Hoya team. The reason for that is because we collected the entire supply chain, and I want you to paint a final picture. And then afterwards, I will go to Alos and we'll close the meeting. But I want you to tell us what you can do for this community, because you are the right company to draw the whole circle. The floor is yours.
Hi, thank you, Jose. It's good to be here and meet old friends and many new people. We are Joya team. We are an optical technologies house offering optical systems development services. We are actually 4 optical engineers and physicists working many years in this field of augmented reality. Actually, we have 70 years of combined experience, and we have developed medical augmented reality systems and automotive head-up displays, military avionics augmented reality, and we also have extensive experience in microdisplay industry, implementing most of the technologies in our augmented reality systems, and also helping other microdisplays companies develop their structure. We provide all kinds of optical services, starting from the idea of new concepts, creating specs and designing the optical systems together with the non-imaging design. We work with Code 5 and Light Tools for many years, and really like those tools. And we also combined our knowledge in new technologies, display and illumination, and provide also testing setups for the systems we develop. We're looking for a cooperation with new optical manufacturers for our customers, and new microdisplays and other Electro Optics technologies. And of course, we're looking for new customers to design new augmented reality and virtual reality systems.
Thank you very much, Asaf. Actually, I have to say that I'm really excited to have companies like AZO Optics and Joya here telling us that they can actually engage the companies. AZO Optics have connected so many companies. Joya, thank you very much for joining EPIC. You have to follow what Andres has done with the EPIC members. Really quite fascinating. I want to close the meeting. First, I want to go to Alos Semiconductor. Alexander, give me a final remark, something to send my friends away.
Oh my God, for me, the final remark. Well, thank you to everybody. It has been a very pleasant meeting as usual with EPIC. It's always a lot of fun to see the interaction. That's really unique. So that would be my closing remark on the meeting in general, and to everybody. In terms of technology, Francesco, you asked about brightness, about micro-LED chips and the colors. Maybe there are just one very short comment from our side. So we are working with gallium nitride, which offers from the bandwidth both blue and green naturally, but also when adding a lot of indium, it also offers red. But in conventional LEDs, you see a different material being today the norm, the in-gap material group basically. And the reason for that is that the efficiency for red nitride LEDs is terribly bad. So we're talking about significantly less than 10% today, whereas in blue we are at 80 for conventional LEDs, and with green not too far away of that, even though there is still the green gap. But for micro LEDs, this is changing. People are looking more and more at red nitrides. And that is not because they love the low efficiency, it is because they love the advantage of being able to manufacture it with the same reactors, with the same processes, to use the same drivers. Driving voltages are very different between nitrides and the in-gap materials. So that is something where we see a lot of movement. And we also see, very interestingly, for exactly the same application, we see different groups working with completely different concepts. So some are going for the RGB with nitride, which would mean that for the red, you would need significantly larger chips to compensate for the lower efficiency to get enough light out. Others are using color conversion, and yet others are going for blue and green with nitride, and then the in-gap for red. Yeah, so
fantastic final remark, Alexander. I have to say, this has been a fantastic meeting. I would like to say that we have two big highlights. The first one, Bosch Sensortec is looking for partners in the laser, fast prototyping, materials, and refractive lenses, and this is a huge opportunity for the ecosystem. Also, we had a great presentation from Dispelix. They're also looking for partners in 3D printed optics, ultra small volume, large field of view microdisplays, and waveguide material. And with this, I would like to say that this meeting really made me happy. It was really a cold day in the Netherlands. It was shy. It was a little bit of raining. The snow is gone. And all I wanted to have is a group with my friends trying to find cooperations. And we did. The meeting was great, but the meeting is not over. Successful companies do the follow-up. So I would like to repeat, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-azure.com, and I will be more than happy to make all these introductions. That goes also for the people in YouTube. We had a lot of YouTube visitors today. If you want to get in touch with any of the participants, just send me an email and we'll make the introduction. My epic friends love to get in touch. On behalf of a fantastic team of medical experts, integrated photonic experts, laser technologies experts, optical designers, the best innovation manager in the world, Antonio Raspa, a team of marketing and event managers, and the great Carlos Lee, the heart of Epic. Thank you very much for making me happy. This is the calendar of upcoming meetings for the online technology meeting calendar of Q1. If you see any relevant for your company, register online. Otherwise, don't miss your logo in the supply chain of the event. Until the next time, wash your hands, wear a mask, and wait to start traveling again. Take care of each other. Bye-bye.